sixth graders, it's Mrs. Zimmerman here. Welcome back from Christmas break. I hope you had a nice, good break, got to relax a little bit, not have to worry about homework, have a good Christmas, all that kind of stuff. So, good break, but we're back to math. And now that we're in second semester, we are starting a brand new section of math. And it is called algebra. What? Yeah, we're going to do algebra in sixth grade. This is crazy. But we're going to start at the very base level. Okay, I'm just going to introduce you to algebra. You're going to learn how to do a few things with it, and it's going to be pretty cool. Okay, so the first thing that we're going to learn are algebraic expressions. Okay, now we are learning an expression that is not the same thing as an equation. An equation has the word equal, right? Equation, equal. So those type of problems are going to have an equal sign. As you see here in my example, there's no equal sign. So we're not going to deal with what equals what. We're just doing expressions, okay? So something like this, okay? Algebraic expressions are going to have numbers. They're going to have operations, add, subtract, multiply, divide, exponents, fractions, okay, all that kind of stuff. And they're also going to have variables. Now, this is probably a new word for you, okay, but a variable is what we call the letters in math. Some really common variables that we use a lot are X, Y, A, B, C, kind of those ones, but really you can use any letter you want. The important thing though is that we always use lowercase letters and we never use the letter L. Why? Why do we never use a lowercase L? Because it looks like a 1, right? So we're never going to use L, and we're also never going to use the lowercase I. Because when you get farther in math, that means something different. But a variable, they're all the letters, okay? And as we go, you'll learn what those letters understand, but for today, you just need to know what a variable is, okay? So I have an expression here for you. It's 5p plus 4. And what your homework is going to ask you to do is to identify the terms, the coefficients, and the constants. Now the terms are just each piece of the expression. Anything separated by an operation. So my first term would be 5p. So I would write just 5p, okay? Because that is on one side of my plus sign. And then I have to look and see what's on the other side of that plus sign, a 4. So then I'm just going to do a comma, and I would write 4. Okay, the next thing we are looking at is coefficients. Coefficients are the numbers that are in front of the variable. So what's my variable here? Where's the letter? P. So what number is right in front of P? 5. So my coefficient is just 5. See how I did that? Okay, and now my last one is the constant. What number is constant? Any number without a variable. So in this case, the only number I have that has no variable, no letter, is 4. So I would write 4 right there as my constant. Okay, terms, coefficients, and constants. We're going to do a few more. Here's my next expression. I've got 3x squared divided by 4y. Woo, we got a lot going on here, okay? So we need to identify the terms, the coefficients, and the constants, okay? Terms. What is on each side of my operation? Well, I've got a 3x squared, so I'm going to write 3x squared with a comma. And what's on the other side of my division sign? 4y. So I'm just going to write 4y. That's it. Okay, the next thing is coefficient. And if you remember, coefficient is number in front of the variable. Variable's letters. So I have an x. What number is right in front of the x? A 3. So my first coefficient is going to be 3. And what's in front of the y? 4. So I'm just going to put a 4 there. And then my constant is anything with no variable. Do I have any numbers here with no variable? No, I don't. So do I have any constants? No, we would just write that there are none. Let's do another one. Okay, here we go. I've got 15 plus w plus 7y. Okay, here we go. My terms. I want to know what is on each side of my operation. So in this case, I've got 2 operations. So I need to go on both sides of each. So we'll start here. What's my first term? 15. What's on the other side of the 15? A w. So I'm going to write w next. And then I have multiplication. On this side, I have a w. Do I need to write the w again? No, it's already up there. And then on the other side of that is 7y. Okay, those are my terms. Now, my coefficient, numbers in front of variables. So, where's my letters? I've got a y. What's in front of the y? A 7. And I have another variable, a w. But here's the thing. Do you see any number in front of the w? I don't, right? But every single variable, even if you can't see it, has a 1 right in front of it. No matter what, every single time, if there's no number, it's a 1. So what is my other coefficient to match the w? It's going to be a 1. And then do I have any numbers with no variable? Yeah, the 15, right? So next I'm going to put 15 as my constant. Okay, hopefully you got the hang of that. We're going to try something new next. Here we go. Next example. Let's read the directions, okay? It says to write the expression using exponents. Okay, so write the expression using exponents. I have 3 examples here for us. So let's look at the first one. Okay, the first one, I have d times d times d times d times d. D times itself, how many times? 1, 2, 3, 4, 5. So if I was going to write this expression using exponents, the easiest way to do it would just be writing d, remember I have to keep it lowercase, d to the power of, how many are there? 5. And that's it, that'd be your answer. We would circle that, call it good, or type it in if you're doing big ideas, right? Okay, next one, number 2. We have m times m times m. Now, notice, it's kind of hard, I know, to see my dots here, but notice how I'm not using the x, okay? Now that we're switching over to algebra, it's going to be important that we don't use the x very often, right? Because then we might think, oh, wait, is that supposed to be a letter or is that supposed to be multiply? I don't know, okay? So when we multiply, now that we're starting algebra, we're almost always going to use the dot, okay? Just so keep that in your head. All right, so my variable here is m, so I'm going to write m. And how many m's are there? 1, 2, 3. So it's going to be m to the power of 3. My last one, let's look. I have 8 times s times s times s times s. So this one's a little bit different, right? Because I have an 8 here. So all I have to do is copy down that 8 and then times s, how many s's are there? 1, 2, 3, 4. S to the power of 4. Now, another way that you might see this written is with no multiplication sign and just 8 s 4, right? Because if you remember from way back, 2 numbers right next to each other mean to multiply. So if we have these 2 right next to each other, that's also saying to multiply. Okay? Here's the next type of example, okay? The only direction I have here is to evaluate. Now, you've seen the word evaluate before, but it's going to come up a lot in algebra. And evaluate really just means to solve. So anytime you see the word evaluate, that just means solve, do whatever they're asking you to do, okay? So here in this one, oh, it's kind of hard to see, but that's a plus sign. Okay, so this one's saying, if I have k plus 10, evaluate that when k equals 25. Yeah, that's an equal sign, sorry. Okay, so here's how we do these. This is very, very important that you show all of your work, okay? So k plus 10, k plus 10. We always rewrite our work when we're doing algebra. Okay, so we start with the original problem, k plus 10. Now, when k equals 25, well, here's k. What does k equal? It tells me it equals 25. So instead of a k, what could I put? 25. So now I'm going to do 25 plus 10. What's 25 plus 10? If you can do it off to the side, you can. Otherwise, I know that it is 35. And when we work in algebra, we go down. One step, next step, next step, next step, next step. Okay, we always work down, and then our final answer will be one number on the bottom, and we circle it. That's how we're going to solve these. So we're going to try a few more, okay? Here's my next one. I've got 4 times n when n equals 3. Still, we're evaluating. So I'm going to start with my expression, 4 times n. 4 times n. Okay, now 4 times n when n equals 3. So I'm going to write down the 4. And what does my n equal? 3. So what's 4 times 3? Yeah, easy. 12, right? You'll get the hang of it. Okay, I've got a new type of example here, but very similar. I've got a divided by b. 2 letters? What? Okay, same exact thing, right? Every time we see a letter, all we're going to do is turn it into a number in these type of examples. So I'm going to just take my expression, a divided by b, and I'm going to rewrite it over here. All right, a divided by b. Now, it tells me, this is so easy, right? A equals 16. So where there's an a, I'm going to change it to 16, write my division sign, and now I have a b. And what does b equal? 2. So it's 16 divided by 2. That's 8, right? That's all you have to do. Every time you see a letter, you put the number in, and then you solve it. Okay, let's try another one. And here we go. Keep at it, okay? We've got 6. I don't know where I got 6. We have x minus y when, oh, there it is. X equals 20 and y equals 6. That's where I got 6. Okay, but back to my original expression, I have x minus y. So x minus y. Write it down. What does x equal? 20. What does 6 equal? Or what? I did it again. What does y equal? 6. So I'm going to put 6 there. And then we just subtract. What's 20 minus 6? You can do it off to the side here if you need to, right? Otherwise, we know that that is 14. Okay, we're going to go on. We're going to try another example that's just a little bit harder. You ready? We have 3x minus 14 when x equals 5. Okay, this is called a two-step expression. Why? Because we have 2 steps. So always, again, just start with what we know. 3x minus 14. Okay, 3x minus 14. What does x equal? 5. So where there's an x, we're going to put 5. Now, let me show you a trick. So we're going to write down the 3. And the best way, because they're right next to each other, right? So if I put 5 here, that looks like 35. No one's going to know we need to multiply. There's 2 numbers next to each other means multiply. So what we should always do is put this in parentheses. 3 times 5 minus 14. And this is just the order of operations problem, right? We have a multiplication and then we have a subtraction. So what do we do first in order of operations? Multiply. So 3 times 5 is 15 minus 14. All right? 15 minus 14 is 1. Let's do another one. I've got y squared minus 6 when y equals 5. Again, we just followed the same steps. So what's my expression? Y squared minus 6. So I'm going to write that down. Okay, next step, y equals 5. So where there's a y, I'm going to put 5. So now we have 5 squared minus 6. Order of operations, we have an exponent and a subtraction. So what are we going to do? Exponent first. 5 squared is not 10. 5 squared is 5 times 5, right? 25. Okay, so I'm going to put 25 minus 6. 25 minus 6, do the math over here, blah, 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 really is 19. Okay, hopefully you're getting the hang of this. Okay, this is all the examples that I'm going to do for today. I know it was a lot, so hopefully you took good notes. You're going to go back, you can rewatch it if you need to, but the biggest thing to remember is when you have an expression, you just substitute whatever it equals. Show all your work vertically down, right? If you're working on a piece of paper, each step should be its own line. And then right here, final answer. Okay, you can do it.